Hello there once again. Welcome back to our Exam Review 3 series. Right now we're doing problem 3 on the review, where we're to write a polynomial with real coefficients, a degree of 5, and zeros at 0, 1, and 2 minus I. Alright, let's actually start with this piece of information. Our first 0 is at 0, so we'll begin with x equals 0. We have another one at 1, and another at 2 minus I. Now remember, in order to get a real polynomial, if you have 2 minus I, you must also have what's called the conjugate, 2 plus I. The conjugate just keeps the real part, the 2, the same, and changes the sign on the imaginary part, the I. So let's also add x equals 2 plus I to our list. Notice also it says that the 0 at x equals 1 has a multiplicity of 2, so let's remind ourselves that that one has a multiplicity of 2. Alright, what we want to do is set all of them equal to 0. Well, this x is already equal to 0. To make this equal to 0, we simply subtract 1 on both sides. The 1 and the minus 1 will cancel, leaving us x minus 1 equals 0. And because the multiplicity is 2, we'll say x minus 1 squared. We can do the same thing for this next part. We can move the 2 minus I over, subtract the 2, and add the I. Subtract the 2, add the I. The right side cancels out completely, leaving 0. And we'll have x minus 2 plus I equals 0. That'll be our next piece. Then we'll have x equals 2 plus I, so we'll subtract the 2 from both sides, and subtract the I from both sides. 2's cancel out, and the i's cancel out, leaving us x minus 2 minus I equals 0. That will be our next piece. So if we count the degrees we have, this x is first power, this x minus 1 is second power, this x is first power, and this x is first power. So we have multiplicities of 1, 2, 1, and 1, giving us a total of 5. That matches the degree we were told in the problem. So now to write the polynomial, we'll start with y equals, again, the leading coefficient a, which we don't know yet, but we'll find in a moment, times x minus 1 squared, times x minus 2 plus I, times x minus 2 minus I. All we have to do now is find the leading coefficient a. To do that, we're going to use the last piece of information on the third line here that says the graph crosses through the point 2, 2. So that means when x is equal to 2, y is equal to 2. And we'll plug those into the equation now. So this y becomes 2 equals a times 2 times 2 minus 1 squared times 2 minus 2 plus I, and then 2 minus 2 minus I. So let's do the math here. 2 minus 1 is 1. Raised to the second power gives you 1. So we've got a times 2 times 1. 2 minus 2, of course, cancels out, leaving us with I. 2 minus 2 here cancels out again. We have negative I. Let's continue. If we have I times I, we'll have I squared. We also have the negative. So let's write all this down. We have a negative. We do the numbers. 2 times 1 is 2. I times I is I squared, and we still have the a. But remember that I squared is equal to negative 1. And all that means is you just change the sign when you see I squared. So this I squared changes to negative 1, which means we change the sign of all this, and we'll have 2 is equal to positive 2a. Therefore, a equals 1. So therefore, our polynomial with complex coefficients is going to be y equals 1 times x minus 1 squared, x minus 2 plus I, x minus 2 minus I. Go ahead and put a box around it. That's our answer to the first part of the equation. So this is what we have when they ask for complex coefficients. To change to real coefficients, we'll have to make some modifications to the complex equation we just found. The shortcut I like to use is to put a second set of parentheses around the x minus 2 in the first positions here. Okay? You might notice that this looks like a difference of squares. You might recall that a plus b times a minus b will give you a squared minus b squared. We can try that here, where our a would be x minus 2 in parentheses, and b would be I. So we'll have x minus 2 squared, and then I times negative I gives minus I squared. The rest of the equation stays the same because all of that was already real. But again, remember that I squared is the same thing as negative 1, and that negative I squared is the same thing as positive 1. So we can substitute this negative I squared for plus 1. Once again, the rest of the equation stays the same. Now, all we have to do is FOIL the x minus 2 squared. So we now have y equals 1x times x minus 1 squared. If we FOIL this out, we'll get x squared minus 4x plus 4 plus 1. Now combine the like terms, plus 4 and plus 1. We'll simply make plus 5. And so our final answer is going to be y equals x times x minus 1 squared times x squared minus 4x plus 5. There you go. So if they ever ask you to do irreducible quadratic, that's what they're asking for you to change all the imaginaries to some sort of quadratic form by multiplying these two parentheses together. All right, thank you for watching. We'll see you soon with more problems.